Hello, everyone. Welcome to the Pachara Talks. And today we are going to design a caching solution. I'm going to talk about caching solution first. In this video, we'll try to understand the caching, the various levels. So let's try to understand what is caching first. Well, caching is the process of temporarily storing data or files in an intermediary location between the requester and the permanent storage for the purpose of making future requests faster and reducing the network throughput. That clears what is caching. I'm pretty sure most of my viewers already knows it because I've completed a lot of videos regarding the architectures, caching, and things like that. And this is 305, but just to set up the stage, I need to talk about what is caching. Now, let's talk about some benefits about the caching, which will help us to put everything in perspective, like why we are doing it. Well, when we explain what is caching, a lot of things are already clear, but let's go a little deep to understand the benefits. The very first is it improves the performance of an application because memory is orders of magnitude faster than disk, and it's in-memory cache that we are talking right here. Reading data from in-memory cache is extremely fast. Then a single cache instance can provide hundreds and thousands of IOPS, potentially replacing a number of database instances, hence reducing the database cost as well. It reduces the load on the backend for the obvious reasons by redirecting significant parts of the read load from the backend database to the in-memory layer. Caching can reduce the load on your database and protect it from slower performance under load. There is situations like e-commerce website or social apps where on certain situations, certain days, the spikes happen of the load, and increased load on the database results in the higher latencies to get data, making the overall application performance unpredictable. And by utilizing a high throughput in memory cache, this issue can be taken care of. It also helps us to eliminate database hotspots. For example, let's suppose there is a celebrity profile or a popular product which always exists more frequently than the rest. This can result in hotspot in your DB, and you require and may require over provisioning of database resources based on the throughput requirements for the most frequently used data. Storing common keys in an in-memory cache mitigates the need to over provision while providing fast and predictable performance. So ultimately, if we need to sum down all the benefits that caching provides us, so if we need to sum down all the benefits that caching provides us, in a nutshell, caching increases the application speed and lowers the cost. It allows us to reuse the previously retrieved data. That's the summation of all the benefits that we talked about. Now, to increase the application performance, caching can be applied at various layers. For example, web layer, application layer, data layer, and network layer as well. Normally, let's check the situation. This will help us because we are into distributed modern application as well. That's what the cloud is all about. So normally, the servers, RAM or random access memory, and in-memory cache engines are utilized to support application cachings. However, if caching is coupled to a local server, then the cache will not be persisting data in case of the server crash. Server gone, your cache gone. And all your user session and things like that that you're storing on the cache for the benefit of the application, gone. That's why distributed systems. Now, most of the applications are in a distributed environment, so it's better to have a dedicated caching layer that should independent of the application lifecycle. And when we apply horizontal scaling to our applications, for obvious reasons, all servers should be able to access the centralized caching layer to achieve the best performance. These are some attributes of the modern application. We're distributing caching layer so that our application is stateless and we can scale it horizontally without losing the information like user sessions. So let's quickly check the mechanism of applying caching on each layer on your architecture. So let's start like different kind of caching that we can apply. The very first is and very common is the database caching. Application performance highly depends upon the speed and throughput provided by the database. And database caching allows you to increase database throughput significantly and lower data retrieval latency. A database cache can be applied in front of any kind of relational or non-relational databases. And some of the databases also provide integrated caching, which applications handle. While you'll find the application even handling the local caching as well. So all those benefits that we talked about, they were all in memory targeted toward the database caching as well. But you will find another one as application caching. At the application layer, caching can be applied to store the result of complex repeated requests to avoid business logic calculation and database hits. Yes, we can apply at the application layer as well. Overall, it improves the application performance and reduce the load on the database and infrastructure. But it depends the kind of application you have. If you have some complex business logic which consumes a lot of compute power, then of course this will help. Now, if you think from the 3-tier architecture, we're done with the database caching, we're done with the application caching. Now it's time for the web caching. Much of the request involves retrieving web content such as images, videos, HTML pages, and caching these assets near to the user location can provide a significant improvement in the page load. This also eliminates disk read and server load time. So now I'm pretty sure you could get it where I'm going. I'm going to CDN. Yes, a content distribution network provides a network of edge locations where static content such as high resolution images and videos can be cached. It's very useful for reading heavy applications such as games, blogs, e-commerce, or product catalog pages, and many more. The user session content contains lots of information regarding user preferences and their state. It provides a great user experience to store the user session in its own key value store, applies to cache for quick user response. So if we have the caching layer for the user session, then this will help us as well. This will also improve the application architecture and help us to make the application stateless, as I said at the beginning. Now, the another one is the DNS cache. We all know that. But yes, when a user types the website address over the internet, the public DNS server looks up the IP address. Caching the DNS resolution information will reduce the website's load time. DNS can be cached to a local server or a browser after the first request, and any other request to the website will be faster because it has the information. Okay, now there is one more, which is the client side. So we can also apply the cache on the client side layer as well. And you have seen it. Client side caching is applied to devices such as mobile or desktop. This caches the previously visited web content to respond faster to a subsequent request. Each browser has its own caching mechanism as well. HTTP caching makes the application faster by caching content to the local browser. So these are various layers where we can apply the caching and make our application more performant and lower some cost. Redis and Memcached. Redis and Memcached are the most popular caching engines, while Memcached is faster. It's good for low structured data and stores data in the key value format. Redis is more persistent caching engine and is capable of handling complex data structures required for an application such as gaming applications. Well, but we are going to talk about from Azure perspective, because this is AZ305, and we gotta explore the Azure Cache for Redis. Yes, it backed by Redis. So we'll explore this Azure Cache for Redis in our next video. Till then, take care. Bye-bye.